All right, so, all right, Tim, what can I draw? You guys said a 1, a 5, 10, or a 20. If I drew 1, what can I draw next?
5, 10, 20.
5, 10, or 20. But this is different. What if I drew a 5?
1, 10, or 20.
Then yeah, 1, a 10, or a 20, because I can't draw 2 5s, 5 twice, right? What if I drew a 10 first?
1, 5, or 20.
1, 5, or 20. What if I drew a 20 first?
1, 5, or 10.
1, 5, or 10. So the sample space for this would be 1, then a 5, 1, then a 10, 1, then a 20, 5, then a 1, 5, then a 10, 5, then a 20, 10, 1, 10, 5, and then 20. 20, then 1, 20, then 5, 20, then 10. Good? Everybody has that? All right. These are the addition rules for probability. These should be in your notes. You should write them into your notes, right? We're filling this stuff out. Adam, go ahead and read.
Two events are mutually exclusive events or additional events if it is impossible for both of them to occur simultaneously. Exclusive means separate.
So the addition rules, if they're mutually exclusive, they can't occur at the same time. Can you be a black lab and a yellow lab at the same time? No. So you can just add their probabilities. What's probably you're a black lab or a yellow lab? Just add their probabilities. What's probability I roll a 3 or a 4? Just add their probabilities. You can't roll a 3 and a 4. This dice, if I roll it, it can't be a 3 and a 4 at the same time. It's either going to be a 3 or a 4 when I roll it. If there is overlap, like we had the one with like a yellow lab and a female lab, right? You add the probabilities, but then you subtract the overlap. Because the yellow female labs are getting counted in the yellow part and they're getting counted in the female part too. They're getting double counted. So just subtract off one of them. These are all in your notes. You should be filling those out. They refer to the same occurrence. So I'm talking about just one roll of dice or one person selected. Because otherwise, I'm not talking about 3 flips of a coin. What's probably I flip a coin 3 times and I get a heads or a heads or a heads. That'd be 1/2 plus 1/2 plus 1/2. 150% chance of getting a heads at least once out of 3 flip coins. That's not correct. Do you guys see the problem there? So we're talking about just one roll of the dice or one flip of a coin. One person picked. So that's an important part of this. All right. Quiz problem number 5 from your homework. You're supposed to change this to 0.63. This is not anywhere else but in your homework, so we're going to go over this one. The easiest way to do that is to draw a Venn diagram. Who's ever seen a Venn diagram before? Good. All right, so this one is, I'm going to draw it better than that. Okay, this one is for mushrooms. This is for pepperoni. The total of them, if I add them up, mushroom or pepperoni, should be 0.63. What information do we have? Mushroom only. Where is mushroom only? The first section, the middle section, or the right section? The first section. This is mushroom only. Just this little kind of crescent moon here is mushroom only. Everybody follow that? Good?
Yeah.
This is mushroom and pepperoni, and this over here is pepperoni only. So what's the probability that goes in here? 0.38. What about the mushroom and pepperoni?
We don't know.
We don't know. How about pepperoni only?
0.16.
Okay, put that where it goes. We know that this whole thing, the green part, is 63%. We know that this is 0.38, we know this is 0.16. If we add in what this is, we would get 0.63. Everybody, are you guys with me on this part? Do you understand what I'm saying? I have told you that they've given you that the mushroom or pepperoni, this section here, is 0.63. So you know that if you add these three up, you get 0.63. There's a larger group that doesn't like mushrooms or pepperoni, right? That's a whole other separate group. And if you're like, I hate mushrooms, I hate pepperoni, I'm not having either one on my pizza, then you'd be the complement. You'd be in that 37% that's the rest. Just to make sure we're clear. So this doesn't add up to 100%. 0.63, the mushroom pepperoni people, plus the people who don't have any mushrooms or pepperoni, that adds up to 100%. So 37% of people did not want any mushrooms or pepperoni. So we're just talking about the mushrooms pepperoni people, the 63% that like that. So here, we could say that 0.63 is equal to 0.38 plus, I don't know what this is, we'll call it x, plus this, 0.16. So why don't you guys take 30 seconds with your neighbors and solve it.
Like 0.09. No, I think she changed it. Yeah, because when I add 38 plus 2, it's so we have to find the middle.
And it's just like,
Okay, so the first thing you do is, and maybe do this, if you're unfamiliar with this stuff, we draw a line down the middle where the equal sign is, so you keep them separate, one side from the other side. So the first thing we should do is combine like terms. There's only one thing over here, so that's fine, but what are the like terms on this side?
0.38 and 0.16.
Yeah, the 0.16 and the 0.3, we can combine those. So we add them up and we get 0.54 plus x. And then we need to get the x all by itself. So how do we do that? Subtract. I need to get rid of this. So I'm going to subtract 0.54 from both sides. And then we end up with 0.09 equals x. Okay? So combine like terms. I'm going to add up these two, right? Good? Yeah.
so mushrooms and pepperoni are not a complement of mushrooms or pepperoni?
No. The complement of mushrooms is not mushrooms. The complement of mushrooms and pepperoni would be not mushrooms and pepperoni. Gosh. Yeah, that gets messy. That would be not both mushrooms and pepperoni. Yeah, let's not go there. That gets into logic, and that's a whole big giant mess. So let's just not worry about it. Okay. So back to our puppies. Don't solve these. I just want to know which ones are mutually exclusive and which ones aren't. Again, The best way to describe mutually exclusive is to describe what is not mutually exclusive. If you can be both, then you are not mutually exclusive. Mutually exclusive would be like, we're over here, we're being exclusive of you. And they're like, well, we're over here, we're being exclusive of you. So if you cannot be like black labs, we have no brown lab, no chocolate labs in our group. The chocolate labs are, we have no black labs in our group. So they're mutually exclusive of each other. Does that kind of make sense? Good. So, male and chocolate. Can you be a male lab and a chocolate lab at the same time?
Yeah.
Yes, so then you are not mutually exclusive. Do you see how that works? Not mutually exclusive. Mutually exclusive means you cannot be both. If you can be both, then you're not mutually exclusive. How about black or yellow?
Mutually exclusive.
Can you be a black lab and a yellow lab at the same time? No. So then these are mutually exclusive. Because you cannot be them both simultaneously. Okay, with your neighbors, 30 seconds, find the last two.
Which is on my phone.
I think that is just example from him. It's just like
Very have something that say,
Okay, so female or black? Not mutually exclusive. You can be both. How about yellow or female? Not mutually exclusive. Good. All right, so this is also on your handout, the very bottom page. Or. This is a symbol for or. It also means union. I like to think of it, this is how I remember it. I think of a guy standing with his arms outstretched. And he's saying, I take all of you. Female or yellow labs, female labs, you're welcome. Yellow labs, you're welcome. I take you both. Right? He's taking both of them. This is how it's written in a Venn diagram. It's all of it. And is different. It goes like this. It's also called the intersection. Right? The intersection of two things. I like to think of it as how I remember it. It's like a bow-legged cowboy standing there. And he's got one leg in A and one leg in B. He's in both. You have to be in both of them in order to be an and. You have to be in the first group and you have to be in the second group. You have to be in both groups. So that's how I like to remember him. This is how you draw him as a Venn diagram. A and B. It's just this part here. Okay? And does not mean you add. And means you're in both. It's harder to be in both. So this is a smaller amount. It's going to be a smaller probability because you have to be in both groups in order to qualify. Here, you can be in either group to qualify. It's larger. It's larger than just one of them. Right? It's more than just one or the other because you can be in either one. So the ors are always going to increase the amount. What's probably you roll a 4 or a 3. It's more likely, right? Because you have more options. So if you think about, example I used to do was like, pretend like you're at a Warriors game and you get picked for the halftime show. If you shoot a basket, you win a Steph Curry jersey. Okay, so that's kind of regular hardness. But say someone else comes along and this is their thing. If they, to win the jersey, they have to shoot the basket and they have to dribble and make a layup. Is that harder or easier than you? Harder. Why? They have to pass both tests. They have to do both of them. Do you guys see it? They have to be in both groups. They have to pass both tests in order to get the jersey. They have to shoot the basket and do the layup. Someone else comes up there, and they say to them, oh, you can either shoot the basket or you have to make the basket or make the layup. Is that easier or harder?
Easier.
Easier, because they have two different ways of winning. Either one. Do you see what I'm saying? So the ors are the easiest, the most likely. Because you can be here, or there, right? The ands are the toughest because you have to be in both groups. That's the least likely. Okay, so we'll talk a little bit more about that soon. Let's take a. Let me find a spot where I can. Let me do a couple more things and we take a break. So let's take a look at this one. You guys have some cards up there. You have an actual deck on your sheet, I believe. So find the probability of getting a king or a queen or a jack. Find the probability of getting a club or a heart or a spade. And then last, find the probability of getting a king or a queen or a diamond.